When human error meets industrial machinery, it starts with a few inches of loose fabric drifting too close to a rapidly spinning steel shaft. In the fraction of a second that fabric snags, the physics are entirely one-sided. The machine has thousands of pounds of rotational momentum behind it. It doesn't hesitate, it doesn't tire, and it certainly doesn't yield to human bone or muscle. It just pulls. The physical consequences are severe. OSHA records thousands of these incidents every year, resulting in crushed limbs, causing severe fractures, permanent amputations, and fatal accidents. The reality of these statistics is that industrial machines rarely malfunction. Most of these accidents occur because an operator decides to bypass a safety protocol or reach into a running machine to clear a jam, attempting to save a few seconds of production time. Because human reflexes are mathematically too slow to beat industrial physics, there is only one reliable way to protect an operator: an unyielding physical barrier that separates human flesh from moving steel. Picture a brand new apprentice walking onto a modern manufacturing floor for the first time. It is an incredibly loud, highly active environment where heavy raw materials are constantly being shaped, cut, and transported. They are immediately surrounded by a massive density of raw mechanical power. Everywhere they step, there are CNC machines carving metal, lathes spinning heavy parts, automated milling machines, and high-speed conveyors. When mechanical parts rotate toward each other, they create pinch points and nip points, converging zones that instantly trap and crush anything caught between them. Additionally, the friction of cutting and grinding violently ejects metal chips and sparks outward into the operator's standing zone. The human body is entirely fragile in this space. Installing and maintaining proper machine guarding is the single most important line of defense against the mechanical forces of the factory floor. Our apprentice spots a jam on the line. Trying to prove they can keep up the pace, they reach straight toward the moving gears to clear it, until a supervisor grabs their shoulder and stops them cold. The supervisor hits the e-stop, killing the power to the equipment. This near miss provides an immediate lesson on exactly what a machine guard is engineered to do. The fixed guard is a permanent barrier bolted over the hazard, blocking access. The interlocked guard severs power, instantly halting motion when opened. The adjustable guard slides open to let material pass, keeping the remaining gap closed. A guard is a highly engineered safety system explicitly designed to override human error and physically block your access to the danger zone. There is a known paradox in safety engineering. If a guard interferes with the machine's normal operation or accidentally creates a new hazard by getting in the way, human operators will eventually figure out a way to bypass it. That requires a gold standard for guard design. It must be remarkably strong, allow for routine maintenance, and not impede production work. The hardware still requires physical verification. Before an operator pushes the start button, they must perform absolute, non-negotiable checks, confirming the guard is correctly installed, entirely free of damage, and securely fastened in place. Next are the secondary system and personal checks. The operator must verify that the safety interlocks and emergency stop buttons are fully functional. Personally, they must confirm their clothing is tight-fitting, eliminating any loose material that could bypass the guard. Even the most advanced physical barrier is completely useless without the procedural discipline of the operator to verify its integrity before every single shift. Staring at the halted gears, the apprentice realizes that bypassing an interlock to save 3 seconds could have easily cost them an arm. It firmly establishes the severe reality behind OSHA's amputation statistics. Fast forward, and that same apprentice is now a highly experienced machinist. They run complex, high-speed equipment flawlessly, and they execute every process with the safety guards fully engaged. When a new rookie steps onto the floor and attempts that exact same unsafe shortcut, our veteran machinist steps in, physically blocking the younger worker's arm before they can reach the moving machinery. Manufacturing safety relies on veterans actively shielding the next generation, fostering a rigid culture where protecting a coworker always supersedes production speed. To keep mastering the skills and safety protocols that protect you and your team on the floor, subscribe to Learn and Grow with Fun.